So several students came to me and asking if there was a path at the university to become a computational biologist, an applied mathematician or statistical physicist working in neuroscience or molecular biophysics. So first of all, I wanted to say that we need to define what is the meaning of today computational biology and what is the meaning of doing mathematics or physics in these areas. So it is true that now the life sciences have reached to the point where there is enough data and enough the data are not understood. That is, there are probably hidden features, something that has to be found in the data that would require to formulate principles, to formulate models so that something can be calculated out of the model, and the prediction of the model could lead to a statistical analysis that could, for example, reveal something new about, for example, the neuronal code, about how neurons find the target during development, how, for example, animals have a strategy for surviving and how this is implemented in the brain code and the brain organization. So finding this principle, making the model, being able to do the simulation, show that the simulation is giving something, and or being able to derive formula that express the ensemble of parameters, where sometimes there are small parameters, large parameters, where it's sometimes very difficult to explore this parameter space without this analytical formula. But I think what is important in this new area is to stick to the goal. The goal is to think biology, to think how life works, how the brain is organized. This is the goal. The goal is not to ask for a biologist a question and prove mathematical correctness. This is not very productive. What we need is people that can think geometry, think deep analysis, deep dynamical system to discover new thing, and probably by going into the biology, they will reveal a new branch of mathematics or physics or chemistry or a new mode of coding if we think about computer science. And so the next question that I got from students is, where shall we go to learn all of this? There is no, today it is true that there is no one place where all of these disciplines are taught. So it is true that, I mean, first of all, 20 years ago it was even worse. I remember when I started, although I was always interested in computation of the brain, how neurons work at different scales, I started as a mathematician working on geometry, how geometry can be quantified. How do we write an equation? How do we solve an equation? And by solving this equation, we will have an understanding of the role of, for example, curvature in the geometry. So this is how I was trained. And then I moved at that time as a pure mathematician to the Weizmann Institute, coming from Paris 6 University, Pierre and Marie Curie University. I moved to the Weizmann Institute, and then I learned really the biology as a trained mathematician. And what I learned at the same time is also applied mathematics, because it is true that it is not, we don't know in advance what is the math that is needed for the question we are going to ask. So at that time, I started really to learn whatever I could, from numerical analysis, applied partial differential equation, stochastic processes, some statistics, statistical physics, anything that would be needed to formulate the question. When, for example, there are many particles, it's important to understand how to model many particles. At which level? Shall we account for all the particles? Shall we make coarse-grained models? And all of these depend, of course, on the type of question we are asking and the type of answer we should expect. We're not going to model millions of particles if we're interested in the flow, where a coarse-grained model can be sufficient. So at that time, I learned at the Weizmann, I learned really the language of biology to the point where I could formulate for myself a question with the criteria that when I will be able to ask an experiment that will be taken seriously by a biologist, this would mean that you arrive to the point where you can think the biology. Now it's true that, so the question that I'm asked today is where to go. So I think that we are still missing, at least in France, or maybe, I think also in Europe, a place where a new generation can be trained with the hardcore mathematics, but not with the goal or poisoning the goal of purity. We should abandon at this stage of history purity for efficacy and for creativity. That is, the math the student should, or the researcher should be involved in, should be the description and new framework to find out features that are hidden in big data or sophisticated model, to give a new way of thinking. For example, how memory is encoded, at which scale. And there are more interesting questions nowadays in the immune system. Where is the immunity located? Or, for example, how the nucleus of a cell is organized, how how we go from gene to 3D organization, which remains mathematically very poorly analyzed, although there are some small success nowadays. So, again, I think asking a question in biology and proving existence and uniqueness of equation should be considered as non-productive. And an education should start with statistical physics, with geometry, Riemannian geometry, for example, dynamical systems, the classical math, but with really the emphasis of the biology, the questions, and also the computational aspect, not proving that a code is converging, but being able to find numerical code. For example, not to simulate billions of particles, but few particles that would represent the system and show that it will work. So this is usually quite tricky. So I would say this to finish, that there is not only a need for a place, or multiple places in Europe that would invest into a program of this type, bringing mathematicians, physicists, computational, computer science, chemistry together to train a new generation. And not only this is to serve a new field, which is going also with the big project that has emerged in the US and Europe about the brain project, about the the Genome Project. But I think there is a new economy that is arriving now, where there is really a need for such training of this new generation. So for the student, my message is that they should, if they are interested in this subject, they should learn as much as they can in the different areas, and in the absence of such a program, find the lab that are exactly doing this kind of work. All right, I hope it will help.